So I looked up some data earlier on what's the average household income in the US. And I found information about 2019, and that they claimed from their survey, X bar was 68,703. Now, the point here is we use a sample like this to estimate the population. So then what we would do is say, okay, that's approximately the actual population. That's my mu symbol right there. So here, I would say something like we believe the average household income in 2019 in the US was 68,703. New York skews that, you think? I don't know, it's a good question. Now, they didn't talk to everybody, right? They only talked to some people. So I am going to look this up. There we go. So average household income. And I get this pops up right away. It said, hey, the median household income. Okay, so they're given median in 2019. So I'm technically wrong there. It's the median, not the mean, but I'm just going to go with it. Median can be a measure of average, but usually we want the mean. Anyway, so they say it's 68,703. So I'm gonna look that up. Let's go over here. Okay, so they're highlighting median household income. It was different than 2008. 18, it went up a little bit. Okay, so that's good. We hope that happens. And this is in table 1A. I'm curious about table 1A. Hey, there's table 1A right there. Let's take a look there. And sometimes when I go to these sites like this, it's readable to me, and sometimes I look at it, what the heck are they talking about? And this one I read over earlier. I didn't think it was too bad. All right, so let's blow this up for you all to see. And they give a lot more information here. Okay, median instead of mean. That's okay, we're just gonna go for it. We're gonna say, yeah, let's make believe it's symmetric and the median is the mean. All households, line 8 here, 2019, the estimate is 68,703. So that's the number I wrote down earlier. Now here they're giving me a margin of error of 904. Now generally when we make an estimate, the margin is in the same units. So if this was dollars, the margin is dollars. So they're saying there's a margin of error of 904. Let's take a look at what that means. So I'm going to add to this comma with a margin of error of $904. Sometimes when we're working with these things, we have two different kinds of estimates. We have a point estimate. And that's what I have up here. This is my point estimate, that it is say, hey, I think the average mu is about $68,703 based on my sample data. But then we have interval estimates, which take into account that we're probably wrong. There's a chance we're wrong. That's not the actual one. I might be close. So then I have this idea of an interval estimate, which is what a margin of error gets at. A couple ways to state the interval estimate. One way is to state the center, in this case X bar, plus or minus the margin of error, which sometimes they abbreviate as ME. So ME stands for my margin of error. Sometimes you'll see in books or articles or homework, the margin of error might be just the letter M. Sometimes people use just E. Sometimes they write ME for the margin of error. This is a mean. So sometimes you might even see EBM stands for error bound on the mean. There's no standard notation for abbreviating the phrase margin of error. You'll see usually one of these four things. M for margin, E for error, ME for margin of error, which is what I usually use, but sometimes EBM, error bound mean, because this is a mean. So my interval estimate here would be, I think it's about $68,703 plus or minus, I'm off by about $904. Now, if I think about that on a number line for a second, so here's my number line. Ooh, that was not a good number line. There's a nice number line. The 68,000 is in the middle. So right in the middle here, I think this is my best estimate for the population. It came from a sample, right? It's not the whole population. But then I think I'm either off by $904 that way, and my calculator said that was 69,607. Or I could be off that way minus $904. My calculator claims that was 67,799. So this bottom part, and let's see, in case anyone's having screen trouble, I better shift this up. You can all see that. So another way to talk about my estimate for average household income, I think it's somewhere between 67,799 and 69,607. So my interval estimate could either be stated by stating the center and the margin of error, or I could state the lower and upper estimates. All right, so this one down here is my lower estimate, and this one right here is my upper estimate. I'm just going to restate what I think based on this sample data, and this is sample data from the US Census Bureau. Now they only run a full census, that's where they try to contact every adult in the US. They only do that every 10 years. So 2010, 2020, next one's 2030. This was 2019, so in between they're always doing these smaller samples. So again, average household income. And now I'm going to state an interval estimate. So there's a few ways to do that. Shorthand, longhand, interval instead of a point estimate. So one way I already mentioned would be to just write, hey, here's the sample mean, plus or minus my margin of error. And so I could say that 68,703 is my center, plus or minus that $904. Another way to state that interval estimate is by stating the lower and upper values. So often we do parentheses, state the lower number, close parentheses, and then the upper number. All right, so this kind of notation here is called interval notation, which you may have seen in some previous math class. So the interval notation for this would be my lower number was 67,799, comma, and this comma here is confusing. Let's not use commas here. And then the upper one, I added this 904 to get the upper. I subtracted the 904 to get the lower. So that was 6,9,607. So when I'm doing an interval estimate, I can either state center, upper bound, center plus or minus the margin of error, or I could state the lower and the upper. So the lower is always the mean minus the margin of error, and the upper is always the mean plus the margin of error. So these are the shorthand ways of doing it. Otherwise, we write it up in a sentence. So something like, we believe that the average household income in 2019 in the US is between $67,799 and $69,607. And well, that's a good comment I just saw in the chat. One nice thing about using the median for something like this is it's less skewed by extreme values, like a state like maybe New York, people make more money on average, or California might make more money on average than most. And actually, I'm not sure about the numbers on each of those, but I think we do have that data in one of those spreadsheets we were playing with last couple of weeks. So when I'm making an estimate, I can either just state, hey, this is what I think the average is based on the sample, right? And that was like my first shot back here. I think the average is 68,703. I could be a little bit more precise by stating, well, I know I'm off a little, so this is my margin of error here. So I could state the margin of error, and that's okay. Or I could just state the lower and upper value. So I don't even state what the average is. I just say, yeah, it's somewhere between this number and that number. Okay. Now, is it definitely in there? The answer is no. I don't know what the population number is. I'm guessing it's somewhere in here, but I don't know. So this is a caution. We don't know for sure if the actual population mean is in this interval. We'll never know. Another thing to note about that is if I look back at where I got this data here, let's see, they have a 1 here, which means there's information about what they mean by margin of error. So let's scroll down and look for that 1. Here it is. Let's blow this up a little more. Oh, I can blow it up this way. A margin of error, they're calling it MOE, is a measure of an estimate's variability. Okay, so that means this estimate could be right, might not be. The larger the MOE in relationship to the size of the estimate, the less reasonable the estimate is, because that's a whole nother discussion we didn't get to. There was one thing. Here they're doing what's called a 90% confidence interval. Earlier I said we were going to use the 95% rule, so we're usually going to make 95% confidence intervals. And what does it mean to be a 90% or 95% confidence interval? That goes back to that picture I had in StatKey earlier. So this picture right here. Every time we say take a sample, we can get 2 things out of that sample for sure. We can get the estimate, and then we can also get a margin of error or an interval. And here, since we actually know the population data, we can compare the interval estimate, and this black line down the middle is the actual population value. And sometimes our green intervals overlap the actual one, but sometimes the sample data does not overlap what's going on with the population. So in this case, 95% of samples are expected to actually overlap the population, but 5% are going to miss. When we do a sample, we never know whether ours is one of the ones that's green or do we have a red one we missed. We don't know that. In this one right here, they claim this is a 90% confidence interval. I'll talk more about this next class. What that 90% confidence interval means is 90% of similar samples will catch the actual mean, but 10% will miss it. It's not a 90% chance that this one is right. It's just, if we did 100 other samples just like this, 90 of them would actually get the real population number, 10% won't, we never know. So that's the interpretation. I'm not really worried about that today, so I'm not gonna write it down right now. I'm gonna talk more about that in next class. Right now, I just wanna get some data and make these estimates. So let's look at another example.